Hello, and welcome to another telecommunication tower safety video. In today's video, we will be talking about safety climbs, an important piece of equipment on the tower that provides the anchorage for a climber's personal fall arrest system. This is part of a series of videos designed to promote conversations about safety in the telecommunications industry, increase safety for everyone in the industry, and especially for tower climbers. We hope this effort will help employers and workers avoid the tragic and avoidable incidents, injuries, and fatalities we've seen all too often in this industry. Let me introduce our team. I'm Jim Maddox, Director of Construction Safety at OSHA. We also have with us Richard Collum, Program Manager at Crown Castle, a large owner of communication towers and TIRAP board member. And next to him is Scott Kisting, Senior Vice President of Muti Sabre Tower Services Company and Chair of the TIRAP Board of Directors. TIRAP is the Telecommunications Industry Registered Apprenticeship Program. As every tower climber knows, the safety climb is a vertical cable that runs from the top to the bottom of the tower. The climber wears a fall arrest harness attached to the cable with a cable sleeve. This equipment is designed to stop a worker's fall if a fall happens. And we've seen many incidents where proper training and use of this equipment saved a worker's life. We've also seen incidents where workers have died or been really seriously injured because the equipment wasn't used properly. This equipment, when used properly, can also reduce the fatigue on a climber, as it allows for a climber to go up or down without the need for double hooking or some other means of ensuring 100% connection 100% of the time. There are many standards that govern the safety climb equipment and how it's used. The OSHA standards have specific criteria for the strength of the safety climb, specifications for the components of a fall arrest system, and of course safe use of the system. Some of the requirements the employer must follow are: inspect the fall arrest system before each use, remove any defective components from service, and have a rescue plan in case you need to retrieve a fallen worker from elevation. Ensure a competent person conducts frequent and regular inspections of the job sites, materials, and equipment. A competent person must be capable of identifying existing and predictable hazards in the surroundings or working conditions, which are unsanitary, hazardous, or dangerous to employees, and must have the authority to take prompt corrective measures to eliminate them. There are also a number of consensus standards that come into play. For example, there are requirements in the TIA standards for the marking of the safety climb. The ANSI standards deal with the design and use of the equipment. For example, they require the manufacturer of the equipment to clearly communicate the design intent in accord with these standards. The FCC also has rules on interference with transmitted signals that may require the use of non-metallic or other non-traditional safety climbs and equipment. And of course, there are the manufacturer's instructions. These are important because the manufacturer will explain the proper installation, maintenance, and use of the safety climb, as well as what to avoid or not do with the equipment. For example, these instructions will tell you about the number of climbers that can be attached to the cable and the loads that are imparted to the tower. The use of this equipment requires us to ensure our employees are familiar with these rules. But to be really safe, employers need to go beyond the rules and implement a safety and health program. There are many systems that you can use, and you can find more about how to set up formal programs at www.osha.gov. Although safety climbs have been around for a long time, it's only in the last few years that we've had consistent application. We want to talk a little bit about how they came to be standard equipment, and Scott and Richard both have a personal history with their development and use. Richard, can you tell us a little bit about your history with safety climbs and how they came into being?
Thank you, Jim. Prior to 2005, we didn't have a clear-cut guidance or standard we could refer to, so that all changed with ANSI TIA 222G Addendum 2. So basically, 12.3 states, unless otherwise required, antenna supporting structures exceeding 10 feet in height and antennas intended for climbing shall be equipped with a minimum of one climbing facility equipped with a safety climb device. To ensure compatibility with the climber's safety sleeve, the cable support system of a safety climb device shall have a stamped or engraved metal identification tag affixed at the base of the structure indicating the size and type of cable. For cable support systems, a 3/8" diameter cable shall be considered as standard in order to minimize safety sleeve requirements. So the two notes that are really important to us are notes 1 and 4. When the safety climb device is not continuous over the entire height, climber attachment anchorages shall be available at a maximum spacing of 4 feet over the height not equipped with the safety climb device. So this applies when we have a trap safety climb. Number 4 is climbing and safety climb devices need not be installed over the entire height of a structure when their installation would adversely affect the performance of an antenna. In such case, the structure shall be equipped with a warning sign or climber attachment anchorages shall be provided in accordance with the requirements of Note 1.
Fantastic, Richard. So I guess part of what you're trying to convey to us is we really want to facilitate the means for a competent climber to access the work site using a safety climb where it doesn't impede with the natural antenna of the tower, and that's for it to be an antenna support structure.
Absolutely correct, because basically everybody knows that the climbing facility and the anchor or the climbing facility system is just a means to get to your workstation. Once you get to your workstation, you're probably going to have to get off the safety climb anyway.
Well, we really want them to, because then we want them positioning so they're able to work effectively, not just relying on their deceleration or the safety climb. They want to be positioned, allowing them to work with both hands on what it is that they're working on. It prevents us from having slips and falls.
Absolutely correct.
And so when we have a situation where the signage is posted at the base of the tower, you know, is that something that excludes a climber or a contractor from doing their pre-climb inspection or PPE inspection?
Oh, absolutely not. It's just, it just warns them that there may be an impedance or obstruction above and they need to plan accordingly.
So when I'm doing my fall protection plan, then one of the things I should be doing as a contractor is inspecting that system prior to using it or considering it part of my fall protection plan.
Absolutely correct.
Because I may be climbing leg C depending on what my scope of work is, and I may have to use a different type of fall protection, or I may have an obstruction with my safety climb.
You're absolutely correct. And that way you can always plan accordingly. If you have a, for example, you may have a rope grab you may have to install at the top for your workers.
Okay.
Yeah. Okay, so Richard, I know you have some personal stories with the fall arrest equipment, and I was wondering if you would share those with us.
Absolutely, Jim. The first time I ever climbed a tower was a 500-foot tower outside of Burlington, North Carolina. It was a 500-foot tower we were doing an inspection on. So at the time I was working for an engineering firm, and training wasn't really part of our curriculum, if you will. We didn't really have a good way to train our climbers, and it just wasn't really prevalent at the time. So my basic climbing setup consisted of a lineman's belt. We had a spreader bar, a sling, and a rebar hook. And so basically when I got to the tower, I climbed with a couple guys who've been quite experienced, and so I climbed 500 feet. And so it was very nerve-wracking for me because I was pretty unsure of myself. And so I didn't trust equipment, and so I had a tendency to hold on to the tower really tight. They call it white knuckling. And by the time I got down the tower, I was exhausted. I could no longer really use my hands, and I was clamping on the structure with my elbows just to kind of keep, so I wouldn't fall. And so the equipment that we have today is so much better. The harnesses we have, the safety equipment in general is just really, really great compared to what we had. The safety climbs have really helped. And so just to relay a personal story that I haven't really shared very much, we were working on a tower in Eau Claire, Wisconsin, about 200 feet up. By this time I had gotten away from free climbing and I started utilizing the equipment I had. And it was really important that I do that. And matter of fact, double hooking and being 100% tied off was second nature. So I was working with some new equipment that we had just gotten. It didn't really have training in it. It was with the double latch, double hook stuff. And I was working about 200 feet and I was pretty uncomfortable. And I don't remember even hooking off to the top, member above me. And somehow I rolled out of the equipment. And I just remember looking down and seeing the hook flying around the leg. And I was like, oh my goodness. I maybe said a couple choice words. And next thing I know, I'm hanging about 250, maybe 200 feet off the tower. And it was extremely nerve-wracking for the guy above me. But you know what? The equipment saved my life. And we went in and finished the job. At the end of the day, I called it in, called an incident, and discarded the equipment.
Well, thank you, Richard. That's really a very, very special story, and I'm sure that a lot of people have stories like this in the industry. It's clear that this equipment has improved a lot and that it's saving lives. It's also apparent that there's still work to be done to make sure that the equipment is working as intended. This will often require the application of SAWS, as we discussed in the first video. SAWS stands for Stop, Assess, Understand, Communicate, and then execute. Now Scott's going to show us some common safety climb problems.
Jim, I want to thank you for the opportunity for us to have this discussion. As you know, our industry is committed to quality and safety, but we've come across the fact that we've got some installations that don't meet those requirements. And we're going to look at some common occurrences, both by crews that are trying to do the right thing, some crews that maybe didn't have the right tools or equipment, and we'll look at some other problems as we go through these. We'll take a look at the picture that's up on the screen now, and here's a case of a modification of a head assembly plate. This is attached to a monopole, and if you think about it, the safety climb, as we've discussed with monopoles, is very important to the climber's safety. The welds on this particular head assembly are not structural welds. In addition to that, improper hardware is being used, and we've got advanced corrosion happening, and we'll look at a couple other corrosion pictures as we go forward through things. Take a look at this next picture, and this is something that we see quite common in our industry and has to be recognized. We've got fantastic people that work in the industry, and they will put a tremendous amount of effort into doing what they perceive as the right thing. This is a horrible failure, should never have been done this way, but it is an example of the intent of people to try to do well. They just didn't know what the standard was. Think about what happened here. They knew that the mount was going to impact the safety climb cable's path. As we talked about, we can't do that. They took the time and effort to drill through the mount, the effort to rig their cable so they could bring it through the mount and have it installed this way because they thought that was the right thing to do. Unfortunately, it impacts the structural integrity of the mount because it wasn't designed to have that hole there. It gives us the opportunity for corrosion, and it also gives us the opportunity for the cable to take wear at that location. Another one that's a good indication of problems that we observe is when we see people install a mount on the tower. We have to remember that cable has the ability to act as a saw. We've seen bandsaws over the years, all of us have used them. Essentially what we have is the cable's in a constant state of movement. When we're installing a mount or other appurtenance, we should be aware of the safety climb cable's path and not cause harm to the safety climb cable or to the mount or appurtenance that we've installed at that location. Another picture that demonstrates that is this next one as we take a look at this mount at the top of the tower. Now people a lot of times will ask, well, what do we do? This is where the planning comes into place. This is where it's important to apply the sauce we talked about before. How do we stop, assess what it is that we're doing, understand how we're going to address the problem that we have, communicate, sometimes with the owner. I don't have the right mount, or I'm going to have to rotate the mount on the tower so the safety climb cable can pass through unobstructed. Remember, TIA 222 Addendum 2 allows us, G Addendum 2 allows us to obstruct the climbing path, but it does not allow us to harm that safety climb cable. And in situations like this, we need to be able to communicate with the owner what the problem is. This is a good example. Here we have a microwave antenna mount that needed to be installed on this tower, and you can see the mounting pipe. The dish is not installed because it's been removed at this point. What we have is the climbing path obstructed and a mount that's designed for the safety climb cable to pass through. When that occurs, we have a climbing path obstruction, and that does require signage in accord with the TIA 222G standard. In addition, it's ideal for a locking cable guide to be installed to protect the cable and the mount from damage of the cable rubbing. A locking cable guide allows us to ensure that the safety climb cable is not going to come out of the guide in wind, weather, or other events that could cause it to pop out. And obviously, if we're routed through the mount, we don't want the cable coming out of the locking cable guide. There is the ability with this particular mount to rotate it slightly on the leg. And if it was rotated on the apex of the leg, then there's the ability to have the safety climb keeper be placed on the outside of the mount. It's important that we place a keeper when the mount's going to be in an area where the cable could rub on the mount and be impacted by the mount, or the mount impacted by the cable. Another example we see here is, here we have an individual that went ahead and tried to solve the problem. The cable was breaking over the mount. They put a cable guide in trying to solve the problem, but in the process exasperated a worse situation. If you observe down here, we've now put additional stress on the coaxial line. This is a coax cable. Think about a tin can from your pop, your soda can, versus a galvanized cable. If you're rubbing the galvanized cable on that soda can, what's going to win? The coax doesn't have a chance. This is carrying telephone calls, this is carrying data, and we've got to protect it. This is a situation where the sauce was not properly applied. Ideally, a different mount may have been selected, but in this case, it should have been considered to route through the mount, ensuring a competent climber could climb past, protecting the cable and the mount with locking cable guides. Just as an option, there are other solutions available. Here we see a head assembly. This is pinching of a cable. Pinching of a cable cannot happen. Trapping a cable can occur. Pinching a cable within the mount and the structure, within the mount and another appurtenance, is not acceptable in accord with the standard. There is no accepted time where pinching a cable should be allowed. Trapping the cable, we've discussed. Coming through a mount, that type of thing, because of a climbing path of obstruction, we can have that occur, but we cannot pinch the cable. It violates the manufacturer's design intent of their safety climb system. It creates a situation where the cable is uninspectable. It also does not allow the system to work together as a fully engineered system. Another example of that is here on this particular tower, and we see that this cable is trapped. In addition, we also see we're missing a step bolt. Step bolt keepers are there for a purpose. Make sure we install the step bolts in accord with the manufacturer and owner's requirements. But this one, I think it's important for us to recognize. There are many solutions to these problems. We have to work together. One possible solution here would be to rotate this mount on the pole, allowing us to come through the hole that's created by the threaded rod path. This does trap the safety climb, but with the locking cable guide, we're going to ensure the climb's not rubbing on the mount, and frankly, this close to the head assembly, cable's not moving that much anyway. But we have to communicate with the client because it's going to be difficult to make the azimuth. There is equipment, there are standoffs that allow us to make our azimuth. We have to communicate, we have to work with one another. This is a great example of pinched. The problem with this is we're not just hurting the safety climb, we're impacting the mount itself and the way the mount performs on the tower. This mount was designed in a specific manner to be installed. We cannot change the engineering intent of the safety climb systems or of the mounts that we install on these structures. In this application, we've got two locations where the mount is pinching the safety climb cable, not allowing the mount to properly seat upon the pole, and impacting the ability of the cable to perform properly. Another good example that we see quite often is going over the top of the threaded rod. We've had many times in the industry where we've had the threaded rod cut into by a safety climb cable. Remember back to the pictures we showed where the cable was cutting into the steel? The same thing occurs on the threaded rod. Two possible solutions, just from looking at this quickly. Understand your real objective is to take your experience, communicate with your client, and give a recommendation of a solution. But two that you could look at is potentially trapping the safety climb cable, installing step bolt keepers on the clip in accord with manufacturer's intended design. Remember, step bolts aren't designed for fall arrest or fall protection. They're for climbing, access, and egress. But the installation of step bolt anchors as designed does allow a means for attachment. The other option is some of the safety climb cable manufacturers or equipment manufacturers have come up with standoffs that will allow us to step the safety climb off the pole at the top, and then you have to have the keepers to support it because you can't have it stepped off on the top and have keepers sucking it back in. You want to keep your path aligned. So there's two quick options on this one to address this situation versus impacting our cable and our mount's ability to perform. Really doesn't need a lot of explanation. Here we're sitting with a guide tower. We've got the safety climb bracket installed at the top of the tower, and it's not installed with all the components. This equipment comes as part of a kit. Imagineering is great. It allows us to come up with ideas and solutions to problems. When it comes to safety climb systems, don't Imagineer them. Install them as the engineer intended, and if you can't, apply the sauce. Don't leave a problem for the next guy on the site. As we've often said in the industry, the next guy is usually one of us. This is an example of somebody working too hard to do things incorrectly again. I just don't understand. How did we get here? Comes back to planning and not understanding that we have to protect that cable. Richard talked to you about how the safety equipment saved his life. We've got people that are trusting, and there's a lot of great work being done and people doing some great things. And we've looked at bad problems and we've looked at some problems here today. Jim Maddox points out the fact that there's a lot of great work happening. We need to recognize that And we need to encourage these people that are willing to work this hard to do it wrong to understand how to plan to do things right. Just another example of modifying an engineered system. Can't do it, people. We just need to stop. Let's stop doing it. Here we see another one where simple rotation of the mount, simple thing to do, simple communication, and we don't impact somebody's health and safety. We need to work together, and we need to be willing to communicate with one another. There is not a single owner or carrier that I work with that wants their safety climbs left unsafe. They all have a sincere desire to trust us as contractors to install it right, which means we have to have the courage to step up and communicate with them when a mount or an installation is going to impact it adversely. Let's have the courage to stand up and say, it's not going to work, but I've got a suggestion. Here's one where we've modified the top assembly, and you know, rotating the mount is what we've talked about a little bit. Shooting the bracket off to the side doesn't work. Unless you're an engineer and you're willing to sign off on this, don't do it. Install it as it was designed and intended, or get help. This is particularly disturbing because here we recognize that somebody identified we had a safety climb system installed improperly. The top head assembly is missing. All we've got is the end sleeve. So they were sent out to install a new safety climb system. Instead of installing it properly or even ordering the proper system, they installed it on the step bolts, which were not intended for fall protection. Step bolt anchors are a different design principle, and when used in accord with the manufacturer's requirements, work as a means of fall protection. Step bolts themselves were never intended to be used as fall protection. And here we have a safety climb system that is rendered unsafe and unusable according to the manufacturer. They did not intend for it to be attached to step bolts. So if you're going to attach it to step bolts, stop. Another one where rotation of the mount would solve the problem. Just let everybody look at that for a moment, and less of me and more of how do we stop doing this? Got a couple problems in this picture to take a look at. Here we see a safety climb breaking over the mount. This is a very unfortunate situation. Unfortunately, that's not all we have. We have the top head assembly improperly installed. So we're stacking errors on top of errors. Remember the weakest link? Here we're graced with multiple weak links. Again, Richard talked about how when we started, he and I free climbed in the industry. We didn't have the fall protection equipment we have now. And we had times where it was close calls for us and different things that happened. This equipment was meant to save lives. This equipment was meant to help others. And when we do stuff like this and leave it behind, how do we actually help one another? As we come to the close of this section, Jim, answering your question and addressing some of it, there's a couple things we have to talk about with PPE. You mentioned it in your beginning comments. It's important for us to understand that PPE must be inspected prior to each use. As such, a contractor is responsible for inspecting that safety climb cable prior to using it as part of their fall protection plan, should they choose to do so. The contractor is responsible by the owner's authority to do that. Owners must inspect and maintain their structures in accord with the TIA 222 standard and their engineer's requirements. But when I go to turn this into PPE, I'm responsible for inspecting it. One of the things that we come across often is corrosion. In an atmosphere that we have, if you identify corrosion, or in this case, we don't have enough tail through the strand vise, the system needs to be tagged out, reported to the owner, so it can be scheduled for correction or replacement. Another one to take a look at and pay attention to when we're doing the inspection is, remember, we're not just concerned about our safety, we're concerned about the safety of the people that use these systems every day. Up to 70–75% of 911 calls, depending on whose study you look at, come through our wireless networks. As such, when we end up having a safety climb cable cut through a coaxial cable, that drops the ability for the carrier to be able to provide that. There is redundancy. There are means for them to do it through other sites, but the intent is not to take a site off the air. As concerning, if not more, and it's hard to see in this picture, but here we have a piece of elliptical flex. We won't get into the conversation whether or not flex should be used upstairs on a microwave antenna or not, but we have a piece of flex, and the safety climb cable. This is essentially just a single copper tube being rubbed on by galvanized wire rope. Jim, this comes back to the fact that we need to protect the system because we're dealing with the safety not just of the contractor on the site, but the owner, the carrier, and the people that utilize our systems. I hope everybody sees that we do have a lot of people that are trying to do very good work in our industry, but we need to work to support one another so we don't leave a problem for the next person. Thanks for the time on this, Jim.
Okay, thank you, Scott. And I just want to say that for some of these situations, OSHA may not be your biggest problems. Scott has seen some problems that are so egregious, where the work was so poorly done, that a contractor could end up facing manslaughter charges at the state or local level. If you're unfortunate enough to have this happen, the prosecutors are going to ask you, why did you do the work this way? And you really need to be thinking about what is going to be your answer. How will you answer the question? Okay, Scott, can you show us some examples of these more difficult situations?
You know, it's unfortunate that we have to even have the conversation about the why would you do that file where, you know, it's not a matter of simple education. This is a question of why did anybody even think they could leave something in this situation? Here we see an example of a safety climb system completely modified. It's just simply a cable that's been taken out, broken over a thimble at the top of the tower, and one wire rope clip. One wire rope clip to support someone's life. No top head assembly. This is no longer an engineered system. This is a very serious situation looking for a place to happen. Okay. So here we see another picture where we have the safety climb cable simply just broken over with one single wire rope clip supporting it. This, as we've talked about, is a problem because it's no longer an engineered design system. It's not going to perform as intended to support or save someone's life. What's very disconcerting about this particular picture is not the fact that, again, we have a cable with no thimble protecting it, only one wire rope clip, but whoever took the picture has their safety slider still attached. So this was used, from what we can surmise, to ascent the tower. I have a question with this being a monopole. How does the person get down from this elevation at this point and maintain 100% fall protection now that they've recognized the safety climb is useless? What a terrible position we put this individual in. We see here another example of somebody taking and coming up with their own proprietary head assembly design. I don't know of an engineer of any competency level at all that would approve this as a piece of a safety system. This one, we've talked about the fact that we've had people hooking safety climbs off to step bolts. This is especially disheartening because here we have a situation to where not only did they move it from where it was supposed to be installed from what it appears, but they've trapped it behind the step bolts, making it very unsafe for the climber. The cable is now running behind these step bolts, and it's supported on a single step bolt. If this system was to load to try to save somebody's life, somebody slips, somebody has to use this system, somebody has to rely on this system, what have we done to that person? How in good conscience can we leave this behind? To Jim's point, it may be the fact that you've got to talk to a prosecutor. I have a harder question. Who's going to talk to their wife or their children? Our industry has come a fantastic way in developing things like this to help keep people safe, and there are fantastic people doing work every day well. To those that are not, please just stop. This one we take a look at, and we've got someone that's modified the system. We can tell this is what's supposed to be on the bottom. They've used threaded rod instead of what comes with the system itself. One of the telltale signs on this particular one when you walk up to the site is if you see the top head assembly at the bottom of the tower, you can probably assume they put the wrong end up in the air. So my hope is all we have to do on this particular install is get the proper bottom bracket and invert the system so we've got things right. It's not our place to judge. It is our place to raise awareness, Jim. And I really do. I thank us all for the opportunity to talk about this. This was left and found on a tower during an inspection. This is the top of the safety climb. It's supported with a rope. Just a rope. In the weather, in the sun, with a half hitch. Prosecutors are one thing. Family members are another. Come on, people. We can do better than this. It's not the only time that we've seen it either. We look at the next picture, we'll see that this is something that's all too much of an occurrence. Again, in this one, we want to call out the fact that here at the bottom of the picture is a safety climb slider, part of the fall protection system. Now, the good news on this particular tower, it's a guide tower. They're going to be able to climb down using their alternate fall protection means and not have to rely on the circus installation. The closing picture for this one is what the first picture was. Not only is it a rope supporting the top of the safety climb, it's doing so out on the end of a step bolt that was never intended to be part of a fall protection system. We've talked about the use of fall protection anchors lightly. Please see the manufacturer engineer's requirements for the use of such a thing, but understand step bolts themselves were never intended or designed for fall protection. I guess in closing on this section of it, Jim, I'd just like to say there are so many people doing great things. For those that are afraid, go ahead and stop. We'll get you help.
Thanks, Scott. I really appreciate all of that good information and sharing your experience with us. Richard, I'd like to come back to you and ask you, what do you think about how we can go about improving the use of safety climbs?
That's a really great question. First and foremost, we want people working on our structures to be safe. And if that means for them to stop when they find an unsafe condition, we want them to do it. If they find a situation, we have a lot of training seminars. And so when we train our TIA vendors, for example, when they do a tower inspection, when they find an unsafe safety climb, we ask them to tag it out and then open a ticket on it. If they have the means and methods to repair it there on the spot, we ask them to do so. If not, we order a new system and have them install it. So safety is paramount to us.
Okay, so you really have an expectation that your contractors will call you if they encounter a problem like this?
Absolutely. It's their responsibility to do so. It's their responsibility to inspect this PPE and ours to maintain it if there's a problem.
Yeah. Well, thank you. I think that that's really important for people to know that it's okay for them to report the problem, and that the primary purpose for reporting it is just to make sure that it gets fixed so that the problem isn't there the next time that somebody climbs the tower.
Absolutely correct.
To recap, tower climbers need to be tied off using a 100% connection 100% of the time. Safety climbs are an important part of being able to do that. For the climb to work as intended and save lives, it must be installed correctly according to the manufacturer's instructions and the TIA standards. If possible, a single climb from the top to the bottom of the tower is ideal, so the climber doesn't have to disconnect, use alternate fall protection, then reconnect. It's important to inspect the climb before using it, to make sure to use it correctly while climbing, and have the training to do so, and that you do not damage the safety climb for future climbers. I'd like to thank so many from across the industry that have been a part of this video series and will be included in upcoming videos. We continue to be humbled by the time, treasure, and talent that so many are providing behind the scenes. We would encourage you to share this video and join us for the next one in the series. Remember, it's through communication that we will ensure safety and quality for this great industry. Additionally, we want to ensure that you are aware of some critical websites to support this industry, and they will be listed in the credits. Thanks for joining us.